Hello everyone, this is the fourth session on oil, hydraulics and pneumatics, and in this session we are going to understand the basics of hydraulics and pneumatic systems. We will be checking out the components of the hydraulic system, components of the pneumatic system, and then after we will be comparing the hydraulic and pneumatic system, and at the end we will compare all the power systems that are used in real life. So let us start with the very first thing, the components of the hydraulic system. Now, when we talk about the hydraulic systems, by the definition, hydraulic systems are the power transmitting assemblies employing the pressurized fluid as a fluid for transmitting the energy from one energy generating source to the another energy using point to accomplish the certain useful work. Now, to justify the definition, I will just explain you how this specific thing basically works. So over here, the pressurizing element is pump over here, and the second, the energy utilizing element is the actuator over here. Okay, so these are the two major things that is discussed in the definition. So pump will generate the energy, so it will supply energy to the fluid, and that fluid will go to the actuator over here, and it will utilize that fluid energy and it will accomplish the work. So this is how the whole system works. Now let us understand all the components one by one. So very first component that you are seeing at the right side is known as the hydraulic actuator. Now, hydraulic actuator is a device that is used to convert the fluid power into the mechanical power. Over here, this is the hydraulic cylinder available. Now, this is the linear type of device. So, what will happen over here? Whatever the fluid that is coming from the pump will be delivered, and that fluid power will be converted into the linear motion. So, this actuator may go up or it may go down. Okay. Now, there are other types of actuators are also available which can actually convert this mechanical this specific energy of the fluid into the rotary motion. That is also possible. So, there are two options available. We can go with the linear actuator or we can go with the rotary actuator. Okay, so this was the very first device. The second device that is most important is the hydraulic pump that is available over here. Now, the hydraulic pump is basically used to force the fluid from the reservoir to the rest of the hydraulic circuit by converting the mechanical energy generated by the motor to the hydraulic energy in the fluid. So, basically whatever the mechanical energy is received by the motor will be transferred to the fluid in terms of the pressure energy by the pump. So this is the basic function of the pump. Now, between the pump and the actuator, there are numbers of valves used. As you can observe, there is one pressure regulator available. This is also a kind of valve, pressure regulator. Then after, you may observe this direction control valve which is available over here. Now, all these kind of valve, there are numbers of valves available. These are just two examples. So numbers of valves are there. They are basically used to control the various kind of thing, like the pressure control valve is used to control the pressure. Maybe there will be a flow control valve which will be used to control the flow, and lastly we are having the direction control valve which are basically used to control the direction of this specific fluid. Now, to provide the energy to the pump, we actually need a motor. Actually, it is not necessary that we always need a motor. As of now, for the example purpose, we have taken the motor. There are numbers of options available in the prime mover. So basically, we need a prime mover to actually supply the energy to the pump. So over here, this is one example motor, from where we are going to get the external energy, and we are going to give that energy to the system. The next thing that you are observing majorly is this oil tank, which is also known as the reservoir. So this is the reservoir which is basically used to hold the hydraulic liquid. Now, usually this is an hydraulic oil. Okay, normally we use the hydraulic oil. And next thing that you are observing over here is the complete piping system. You can observe that the pipes are going from starting to end. Now, this specific piping system carries the hydraulic fluid from one place to another place. This is basically a kind of transportation system throughout the whole area. Now, the next thing in the piping system you are observing is the filter part. So, the basic filters are used to remove any kind of foreign particles so as to keep the fluid system clean and efficient, as well as it basically avoids the damage to the actuator as well as valve due to the foreign particles. So, the last and not the least is basically the system of the pressure regulators. Now, basically pressure regulators are the devices which actually required to keep the level of pressure in this specific hydraulic system. If the level goes up, the hydraulic regulator will control that specific pressure level. If it goes down, it will help to maintain that specific pressure. Ultimately, the pressure regulators are devices that actually controls the pressure of the fluid through the specific system. So, these are the all components used in the hydraulic system. Now, let us check out the working of this complete hydraulic system. Now, before talking about the working, let me just show you the diagram of the same system. This is just a basic layout. This is known as the basic layout of, or you can say the line diagram of the system. Now, this specific drawing that is available in the red color is basically the symbolic representation. Symbolic representation. Now, these symbols are not just a typical symbol, they are the actually generalized symbol which are certified by ISO. These are the ISO certified symbols which are used over here. So, as you can compare, this system is actually similar. We are having the oil tank over here, this is the reservoir, we are having reservoir over here. Then after we are having filter, this is the symbol of the filter, a pump, this is the symbol of the pump, as you can see the arrow over here which is indicating the direction of the flow. Then after we are having the symbol of the motor, this is the symbol of motor, pressure regulator, this is the complete symbol of the pressure regulator. Now, if you talk about the direction control valve, the major symbol is over here. Okay. So, as you can observe, there are total 3 positions for the direction control valve is available. So, over here we are having the total 3 position. This is the first position, this is the first position, this is the second position, and this is the third position of the direction control valve. Okay. Then after, at the end we are having the actuator which is indicated with the symbolic representation over here. So, this is the symbolic representation and this is the line diagram, or you can say the basic layout of the system. Now, what will happen over here? So, whenever you start the system, what will happen? The pump will actually collect the oil from the reservoir. Now, this oil will pass through this specific filter. Now, what is the work of the filter? Filter will actually remove the extra particle, or say unwanted solid particles from this oil. So, it will send the clean oil to the pump. Now, the function of this specific pump is to take the mechanical energy that is generated by the motor and transfer this energy to the fluid. So, whatever the output fluid is there will be the pressurized fluid. Now, the next thing that you are observing is the pressure regulator. Now, if you observe in this specific ISO diagram, the pressure regulator looks something like this. So, what will happen if the pressure of the system goes ahead? What will happen? The pressure regulator will actually send some of the fluid towards the reservoir once again. So, it will try to control the fluid pressure. So, if this kind of situation comes where the pressure goes up in the system, in that case pressure regulator will get activated and it will send some of the fluid back to the reservoir. Otherwise, it will keep sending this pressure, this fluid to the system. Now, further, if you go ahead, I am having a direction control valve. Okay. Now, what basically happens whenever the direction control valve is in the position number 1, as you can observe, I have reached over here in this ISO diagram. Now, over here this specific thing T mentions that now the line is closed as of now. Okay. So, to turn on the line, if I want to move this actuator up, okay, if I want to move this specific load up, what I need to do? I need to shift my pressure in this specific direction. I need to move this cylinder in the upward direction. So what I need to do? I need to move my direction control valve for this situation. Clear? So what will happen if I move this specific direction valve, control valve in this situation? The arrow will come over here. So this arrow will move over here. So this specific flow will move in this direction, and as you can see, this specific flow will move in this direction. I am showing in both the diagrams. So what will happen? This cylinder will be pressurized from the bottom, and this pressurized cylinder will basically move this load in the upward direction. At the same time, the oil that is available on the top of the piston will be returning back from this pipeline. Okay, in this specific diagram, this is the returning oil, and which will return in this path. As you can observe, this is the path. So this path will come over here, and this is the returning oil. Okay, so in this diagram you are having something like this. This is the returning path. This is how the load will be lifted. Now if you want to return the load, instead of moving this specific section, activating this specific section, you have to activate this specific part. Okay, let me just clear everything. So you have to activate this specific part. So what will happen? The flow that is coming from the flow will be connected something like this and like this. So what will happen over here? Whatever the flow is coming from the pump will be directed to the second path. That means in this line diagram, this will be directed like this. So it will help the load to lower down, and at the second pipeline, you will observe that whatever the oil that is available below the piston will move in this specific direction like this. Okay, so this is how the whole system will work. Now most commonly these hydraulic systems are actually high pressure system, and they will follow the closed loop system. Okay, now let us move towards the pneumatic systems. This is the line diagram for the pneumatic system, and as you can observe, this looks almost similar. So first of all, let us understand the definition and let us understand how this system works. A pneumatic system basically carries the power by employing the compressed gas. Now compressed gas is generally the air, which is the atmospheric air, as a fluid for transmitting the energy from an energy generating source to the energy using point to accomplish the useful work. So basically, as per the definition, what we are having the air that is coming from the atmosphere. It is getting pressurized with the help of the air compressor, which is the energy generating source. Now from the air compressor, this air will go to the energy utilizing device, or say energy using device, which is the air actuator. Okay, and lastly, this air actuator will do the useful work. Over here we are having almost the same circuit, but as you can observe, the air is coming from the atmosphere and air is going back to the atmosphere. There is no energy reservoir, or say there is no water, or say air controlling system, or say air containing system. Okay, so let us quickly check out what are the different types of component which are available in the pneumatic system. So over here, as you can observe, it is looking similar to the hydraulic system. So let us quickly check out what are the component differences available. Very first thing, as you can observe, this is the air filter instead of the normal filter. The air filter will filter the air. The filtered air will go to the air compressor. It is not going to the pump. It is now known as the air compressor, which is taking the energy from the motor and transferring the energy to the air. So the output air will be the compressed air. Now when we talk about the compressed air, always remember that compressed air will be also having the higher temperature. So it will get hotter due to the pressure increase, and to reduce that temperature, the air cooler device is actually used within the system. Okay, now once the air is cooled, it is sent to the storage reservoir, which is actually the part of the system. Now in this specific storage reservoir, we are having the compressed air. Now to control the pressure of this specific system, what actually is done, the pressure of this storage is continuously measured. Now if the storage pressure of this container is low, the switch will be closed. This specific spacer switch will be kept closed. Now due to that, what will happen, power supply continues and motor continues to run. Once the pressure reaches at the required pressure, at that time this pressure switch will get open and the motor automatically stops. Okay, so this is the basic closed loop system which is working over here. Whenever the pressure is low, the system will continue to work, the motor will continue to run. Once the pressure reaches at the required level, the motor will automatically shut down with the help of the pressure switch. This is how the basic closed loop system within the pressure control device works. Now, if you need the pressure of the air, that means if you want to work with this compressed air, in that case what you need to do, you need to do the similar thing that we are doing in the hydraulic system. You need to actually turn the system on the level 1. So what will happen, the air will go like this, and from here the air will push this piston in the upward direction, so load will be lifted. At the same time, the air that is available above the piston will return using this return path, and it will send back to the atmosphere. So basically, as you can observe, the components are almost same as the hydraulic system. The major difference is we are having the air compressor and we are having the air cooling mechanism available. And at the end, if you observe, the hydraulic system was the closed system. This was the hydraulic system, and as you can observe, there was an oil tank available which was showing that whatever the oil is coming back, the same oil is going to be used once again. Over here, the air is coming from the atmosphere and air is going back to the atmosphere. So this kind of systems are called as the closed loop, open loop systems that we need to understand. Now let us quickly check out the comparison between hydraulic and the pneumatic systems. So this is the basic comparison between hydraulics and pneumatic system. Very first, if you observe, in the hydraulic system, majorly we are using liquid as a fluid. Most probably we are using oil. When it comes to pneumatic system, we use the compressed air. Normally we use the air as the fluid. Now as we are using the oil as a fluid, we can go up to the 700 bar. So we can have higher pressure for the operations. But as we are using the pneumatic system, air as a pneumatic system, in that specific case we are having only 5 to 10 bar operating pressure. So basically pneumatic systems are used for the lower class operations. When we need higher pressure, higher range, in that specific case we have to use the hydraulic system. Now as we observed, the hydraulic systems are the closed systems and the pneumatic systems are the open system. Next, the systems basically slows down when the leakage occurs, because the systems are the closed system. If there is a leakage of the oil, in that case pressure of the system will get reduced and the system will lower down. But as the air is used in the pneumatic system and the system is the open system, because the atmosphere, from the atmosphere we are taking the air, in that specific case even if there is a leakage, it does not affect that much to the system. There are two major components comes into picture. Very first, the pneumatic system is taking air from the atmosphere, so there is no issue of the air. And second thing, the pressure, the operating pressure is very low, so there will be no major effect of the leakage on the system. Now when we talk about the valve operation in the hydraulic system, they are actually difficult. Even if you try to close the tap whenever it is a higher pressure, the water tap, that is also very difficult to close. But and over here actually we are using the very high pressure system, so it becomes very difficult to close any kind of valve or to open any kind of valve. On the other side, the valve operations in pneumatic systems are very easy because they are the pneumatic systems simply. And as the hydraulic systems are using the heavy loads, there is a almost 700 bar pressure. In that specific case, we have to use the heavy machineries, and that is why we are having the heavier weights. In the pneumatic systems, we can use the lightweight equipments, that's why it is having normally the lighter weights. Now, when it talks about the hydraulic system, the pumps are basically used to provide the pressurized liquid, and in the pneumatic systems, we use the compressors to provide the compressed air. When it comes to hydraulic system, always remember that there are oils available, and many times some of the oils are flammable also, so it is very unsafe and it is actually fire hazardous thing. When it comes to pneumatics, air is actually free from the fire hazards. And lastly, as we are using the oil in the hydraulic system as a hydraulic fluid, the lubrication is actually not required. It is the automatic lubricating system. And in the pneumatic system, as we are using the air, the arrangement of lubrication is actually needed separately. So this was the major comparison between hydraulic and the pneumatic system. Now we are going to compare all different power systems that are normally used in the real life. So most commonly we are using the mechanical systems. Mechanical systems are basically the gears, belts, ropes, shaft. All these are the mechanical systems. Then after we are using the electrical power system like electrical cables, magnetic fields, okay, all these things are the electrical system. Then after we are using the pneumatic system and the hydraulic system that we are learning right now. So let us quickly check out what are the properties and in which specific property which system is best. So when it comes to input energy source, mechanical system uses the IC engine or electric motors. The electrical engines or say electrical systems uses the IC engine or water or gas turbines, because the electricity is generated from the water or gas turbines or IC engines. At the same time, for the pneumatic, we need to increase the pressure. So the pressure increase can be done using the IC engine or the pressure tank. In the hydraulic also, what we need to do? We need to increase the pressure of the fluid. It can also be done using the IC engine, electric motor and the air turbine. All three are compatible. Now, for transferring the energy within the system, what we can use? In the mechanical systems, we can use the lever to transfer the energy. We can also use gears, we can use shafts, we can use belts, and we can also use the ropes to transfer the energy. When it comes to electrical system, we normally use the electrical cables or say electric wires or magnetic field or electromagnetic field to transfer the electricity. In the pneumatic system, as we all know, hydraulics and pneumatics uses the similar kind of mechanisms. We actually use pipes and the hoses to transfer the energy. The air will be transferred through the pipes and hoses. At the same time, in the hydraulics, water or say oil will be transferred through the pipes and hoses. Now, what is the energy carrier? When we talk about the energy carrier, basically who is carrying that specific energy? When it talk about mechanical system, the energy carrier will be the rigid or any kind of elastic objects that we are using like belts, ropes, etc. In the electrical system, the energy carrier will be the electrons. The electrons will be actually working as the energy carrier. In the pneumatic system, we are using air as the energy carrier. The compressed air will go through the pipes and it will transfer the energy. And in the hydraulic system, the hydraulic oils or say hydraulic liquids are called as the energy carrier. Next, when we talk about the power to weight ratio, what is the power to weight ratio? What is the weight and in compared to that, how much power it is giving? If I take the ratio of this specific one, the mechanical components are the poorest one because they are very heavy, and against that they actually transfer very less power. The best one are the hydraulic and the pneumatic systems. Electrical system comes in between two things. Then after, when we talk about the torque or inertia transfer, we are talking about the transferring, not the generation. Always remember that. So when it comes to torque or inertia transfer, the mechanical components are actually very low in that case, because the mechanical components are having very higher inertia. They cannot actually afford sudden responses. Okay, in that specific case, hydraulic systems are the base system. Pneumatic and electrical systems comes in between. When it comes to stiffness, the base systems are always hydraulic systems. The worst system in case of stiffness are the electrical systems, and other two, the mechanical systems and the pneumatic systems, are okay systems. The response to speed, when it comes to the speed, the response to speed is based in the electrical system. All of a sudden changes are actually being adjusted very quickly by the electrical system. The other systems are actually giving you the fair system changes. When it comes to the cost, the relative cost are actually very good in the mechanical and the electrical systems. When it comes to cost to the performance ratio, mechanical electrical systems gives you the best output. Hydraulic and pneumatic system relatively slightly costlier than the previous ones. In case of the component controls, the control in the electrical system is the best. Other three are okayish. And in the last one, when it comes to motion types, mechanical and the electrical system mostly gives you the rotary output. There is no linear output available in the mechanical or the electrical system. Even if it is available, it will be through the rotary outputs. Okay, the rotary will be changed to the linear systems. But when it comes to pneumatics and hydraulics, they can give both linear also and the rotary also. So this was the major comparison between the mechanical, electric, pneumatic and the hydraulic systems. So I hope you have understood the basic things. Keep learning. Have a good day.